Voyager 1 began its journey on September 5, 1977, when NASA launched the spacecraft on a mission that would eventually become one of the greatest explorations in human history. Originally, its purpose was simple: study the outer planets of our solar system and send valuable information back to Earth. Alongside its twin spacecraft, Voyager 2, it was expected to operate for only a few years. No one imagined that decades later, it would still be traveling through the darkness beyond our solar system. As Voyager 1 moved farther from Earth, it transformed humanity's understanding of space. During its encounters with Jupiter and Saturn, the spacecraft captured extraordinary images and scientific data. It revealed violent volcanic eruptions on Jupiter's moon Io and uncovered the frozen, mysterious surface of Europa, a moon scientists now believe may hide an ocean beneath its ice. These discoveries completely changed the way researchers viewed distant planetary systems. After completing its primary mission, Voyager 1 continued deeper into space. Instead of shutting down, it kept traveling farther than any human-made object had ever gone before. Year after year, it crossed regions no spacecraft had explored. Eventually, it reached one of the most important boundaries in astronomy: the heliopause, the edge where the sun's influence fades and interstellar space begins. Crossing this invisible border marked a historic moment. Voyager 1 became the first spacecraft to enter interstellar space, a region filled with unknown particles, magnetic forces, and cosmic radiation. Scientists expected this area to be quiet and mostly empty, but the data told a very different story. The spacecraft detected waves, plasma activity, and strange disturbances moving through the darkness. Some of the signals received by Voyager 1 surprised researchers because they did not fully match known cosmic patterns. Certain physicists, including Dr. Michio Kaku, discussed the possibility that these unusual readings could reveal new information about deep space. Some scientists believe the signals may come from interactions between interstellar particles and magnetic fields. Others think they could point towards structures or phenomena not yet fully understood. Operating billions of miles from Earth is an enormous challenge. Voyager 1 survives in freezing temperatures while enduring radiation and extreme isolation. Communication with the spacecraft takes many hours because radio signals travel across unimaginable distances. To keep the mission alive, NASA engineers gradually shut down systems that are no longer essential, conserving the spacecraft's remaining power for as long as possible. Despite its age, Voyager 1 continues to provide important scientific discoveries. Its instruments revealed that interstellar space is far more dynamic than scientists once believed. Researchers detected pressure waves traveling through space, likely caused by distant stellar explosions such as supernovas. The mission also showed that the heliopause itself is not stable. It shifts and changes depending on solar activity and forces from the surrounding galaxy. Some researchers have even suggested that certain unexplained observations might one day help scientists better understand dark matter, the invisible substance believed to make up much of the universe. Although dark matter cannot be observed directly, its gravitational effects influence galaxies and cosmic structures. If future analysis connects Voyager's discoveries to these mysteries, it could reshape modern physics. Voyager 1 also carries one of humanity's most symbolic creations, the Golden Record. This special record contains sounds, greetings, music, and images representing life on Earth. It was designed as a message to any intelligent civilization that might encounter the spacecraft in the distant future. In many ways, it serves as a time capsule of humanity traveling endlessly through the stars. The success of Voyager 1 continues to inspire future space exploration projects. New concepts, including missions aimed at reaching nearby star systems, build upon the path Voyager opened decades ago. Scientists hope future spacecraft will travel even faster and explore regions far beyond the reach. More than just a machine, Voyager 1 represents humanity's curiosity and determination to explore the unknown. Its journey has lasted for more than 40 years, yet it still continues across the vast emptiness between stars. Every signal it sends back reminds us that the universe is filled with mysteries waiting to be discovered. Even when Voyager 1 eventually falls silent, its story will live on. It has already changed humanity's understanding of space and our place within the cosmos. Far from Earth, drifting through interstellar darkness, Voyager 1 carries a small piece of humanity with it, a lasting symbol of exploration, discovery, and the endless desire to understand the universe. For decades, Voyager 1 has continued its lonely voyage through interstellar space, moving farther away from Earth every second. Today, the spacecraft is more than 15 billion miles from our planet, traveling through a region no human technology had ever explored before. Even at that unimaginable distance, it still communicates with NASA using a transmitter far weaker than a household light bulb. The signals are faint and slow, taking more than 22 hours to reach Earth, yet they continue to carry information from the edge of the known solar system. As Voyager 1 entered interstellar space, scientists expected conditions to become calmer and more predictable. Instead, the spacecraft encountered an environment filled with turbulence, magnetic activity, and energetic particles moving through deep space. Researchers discovered that the boundary surrounding our solar system behaves more like a constantly shifting ocean than a solid wall. Waves generated by solar storms travel across enormous distances, eventually reaching Voyager and causing disturbances in the surrounding plasma. One of the most fascinating discoveries involved mysterious plasma vibrations detected by the spacecraft. These vibrations allowed scientists to estimate the density of interstellar material around Voyager 1. Surprisingly, space beyond the solar system appeared denser than researchers had predicted. This unexpected result challenged earlier theories about the structure of interstellar space and suggested that the galaxy around us is far more active than previously believed. The spacecraft also revealed how the Sun influences regions much farther away than expected. Even after crossing the heliopause, Voyager continued detecting evidence of solar activity interacting with interstellar particles. This showed that our solar system is not isolated but connected to the larger environment of the Milky Way galaxy through magnetic fields and cosmic radiation. Keeping Voyager 1 operational has become increasingly difficult. Its power source slowly weakens each year as radioactive material inside the spacecraft loses energy. Engineers carefully manage every remaining watt of power, turning off heaters and scientific instruments one by one to extend the mission for as long as possible. Some parts of the spacecraft now operate at temperatures far below what engineers originally thought possible. In recent years, Voyager 1 experienced several technical problems that worried mission controllers. At one point, the spacecraft began sending back unreadable data, creating fears that communication had finally been lost forever. After months of investigation, NASA engineers traced the issue to a malfunctioning computer system aboard the spacecraft. Using decades-old documentation and creative problem-solving, they managed to restore communication and recover meaningful data. The success demonstrated both the brilliance of the original design and the dedication of the engineers maintaining the mission. Scientists continue studying Voyager's measurements because they may help answer some of the biggest mysteries in astrophysics. The spacecraft's data contributes to research involving cosmic rays, magnetic fields, and the interaction between stars and interstellar space. Every new reading provides clues about the hidden structure of the galaxy and the forces shaping the universe on enormous scales. There is also something deeply symbolic about Voyager 1's endless journey. Long after humanity changes and civilizations evolve, the spacecraft may continue drifting through the galaxy for millions of years. The golden record aboard Voyager carries greetings from Earth, sounds of nature, music from different cultures, and images of human life. It was created as a message from one small world to the unknown universe beyond it. Some scientists believe Voyager 1 could eventually pass near another star system thousands of years from now. Although the spacecraft will likely be inactive by then, its silent presence will remain as evidence that humanity once reached beyond its home planet and attempted to touch the stars. Voyager 1's mission has already exceeded every expectation imagined in 1977. What began as a planetary exploration project became humanity's first true step into interstellar space. Its discoveries continue shaping modern astronomy, while its journey reminds the world that exploration does not end at the edge of the map. Beyond every boundary